Hi, this is John Isles and welcome to Geometer's Paradise. Today I'd like to talk to you about conditional statements. This is the first lesson in a series of lessons where we discuss deductive reasoning and how it applies to geometry. So once upon a time somebody probably came up to you and said something along the lines of, if you clean up your room you can have some ice cream. And so maybe you went into your bedroom and you cleaned it up the best you very could. And when you were done, you got taken down the street to the ice cream shop and you got to eat some ice cream. Okay? This is an example of a conditional statement. A conditional statement presents something that you have to do and then something that you get as a reward. The word conditional contains the root word condition, which means the state of something or maybe a dependency, and then it has the suffix -al, which means act. So conditional could mean to act on a dependency. The word statement simply is a declarative sentence. So a conditional statement is acting on some dependency to make something happen, some declarative type of deal. So in our example, cleaning up your room is the condition and getting some ice cream is the result of having that condition fulfilled. So it turns out that life is full of all kinds of little rules like this, and so is math that we've seen at all levels of geometry. But if we look at conditions and rewards, we can say, hey, suppose M is the midpoint of AB. What does this mean? We learned a long time ago that if I have a midpoint, that means that the segments on either side of the midpoint are equal. So the reward for a statement like M is the midpoint of AB is that AM is equal to MB. The segments on either side of the midpoint are equal. Or perhaps we have a statement like ACD and DCB are a linear pair. The reward for that statement is that ACD plus angle DCB is equal to 180 degrees, a cause and an effect. Now we traditionally write conditional statements in an if-then format. So if I want to take this condition and reward that we talked about earlier and write it as an if-then statement, we might say something like this. If M is the midpoint of AB, then AM is equal to MB. Or perhaps we could say if angle ACD and angle DCB are a linear pair, then angle ACD plus angle DCB is equal to 180 degrees. So these are more formal if-then style conditionals. In math and science, the if part of the sentence is commonly called a hypothesis, and the then part is called a conclusion. So if I have an example like if two lines are perpendicular, then they intersect to form four right angles, the hypothesis is that two lines are perpendicular, and the conclusion is that two lines intersect to form four right angles. Notice that I did not use the word they when I wrote my conclusion. Pronouns are bad. Alright? Pronouns are used in if-then statements, but when you separate them into hypothesis and conclusion, you need to make sure that you are telling what they is. So don't use the word they. Substitute the actual noun, which comes from the first part of the sentence. Two lines intersect to form four right angles. Here's a practice. If B is between A and C, then AC is equal to AB plus BC. Take a moment and write down what you think the hypothesis and the conclusion is. Okay, now the English language is tricky. Conditional statements are not always obvious. Look at these examples. Here the statement is written backwards. Two lines intersect to form four right angles if they are perpendicular. The hypothesis is that two lines are perpendicular. The conclusion is that they intersect to form four right angles. Alright, it's written backwards. Sometimes it could just look like a statement. perpendicular lines intersect to form 4 right angles. I call this a loaded sentence. There's a lot of stuff going on here. The subject means something, the conclusion means something. So you have to kind of figure out what's going on. The key to determining the hypothesis and conclusion is to ask the question, what happened first? Okay, so up here, we had lines that were perpendicular, and the result was that we got 4 right angles. Down here, we're like, what happened first? Well, we had perpendicular lines, and they intersected. The result was that they formed 4 right angles. The hypothesis is always the thing that happens first. It's the subject of the sentence. The conclusion is always the thing that happens as a result, and it's the predicate of the sentence. Alright, your assignment then is to go ahead and attempt the practice problems. Here, you're just identifying hypothesis and conclusion. Down here, you're thinking back on some of the things we've already learned in geometry and coming up with the conclusion that results from each of these statements.